Now we've seen what an inconsistent system looks like in terms of the graphs of the two equations. Here, if you remember, you've got two lines that are parallel, which means they never intersect, which means there's no solution, right? But what if we're not looking at the graphs and we had chosen instead to do elimination or addition, or if we had chosen to do substitution? So using the method of addition, I take the first equation, x plus y equals 5, and then I would subtract the second equation. So let me just distribute the minus sign all the way through. Negative x minus y equals negative 3, right? If I multiply both sides by negative 1. All right, then adding the two equations together, I get 0x plus 0y. So notice both variables are eliminated, equals 5 minus 3 is 2. So what I get is this equation, 0 equals true, which is just preposterous. That's a false statement. So if you're doing addition and you eliminate both variables and you end up with a false statement, then we can say that we have no solution. Similarly, suppose I was doing the method of substitution. Let me take the first equation, x plus y equals 5. So this is like equation number 1. And let me solve for y. I'll subtract x from both sides. So negative x plus 5. And let's substitute that into equation 2. So this is number 2 here, which is x plus y equals 3. So I'm going to take y, which is the same as negative x plus 5, and replace the y with negative x plus 5. So x plus negative x plus 5 equals 3. So x plus negative x is 0, plus 5 is 5 equals 3. So again, all the variables go away, and I'm left with a false statement, which tells me that I've got no solution. So again, when we have an inconsistent system, we could see either by graphing it, that you've got two parallel lines, so there's no solution, or by the methods of addition or substitution, we get a false statement out, so there's no solution.